The story begins in the winter shadows of a Europe at war, where German armor, once seen as unstoppable, found itself pushed to its limits. By late 1941 and early 1942, German High Command had already received alarming reports from the Eastern Front. The Wehrmacht, previously confident in the Panzer III and early models of the Panzer IV, now faced a battlefield reality unlike anything they had expected. Soviet T-34s were appearing in growing numbers, moving with sloped armor that deflected fire, wide tracks that gripped mud and snow with frightening ease, and a mobility that stunned German tank crews. Guderian's letters from the front echoed like emergency sirens. He wrote in November 1941 that the T-34 was vastly superior to our best tanks. A foreboding realization settled over the German High Command. If the Wehrmacht did not respond, the balance of armored warfare would shift decisively in the Soviet Union's favor. It was in this environment of urgency that the idea for a new, more powerful medium tank was born, one that would combine firepower, armor, and mobility in a way Germany had not achieved before. The development process began in early 1942 under the direction of the Waffenamt, the German Army Weapons Agency. Daimler-Benz and MAN were tasked with producing competing prototypes. Engineers studied captured T-34s closely, rolling them into German facilities for examination. They measured the angles of the sloped armor, studied the track layout, and even examined the turret design. For the first time, German tank designers openly admitted they needed to emulate a Soviet innovation. Yet Adolf Hitler would transform what began as a practical engineering project into something far more ambitious and far more complicated. Early design drafts recommended a 35-ton medium tank, armed with the 75 mm KWK-42 L-70 high-velocity gun. But Hitler intervened repeatedly, demanding thicker armor, wider gun mantlets, and additional modifications meant to guarantee superiority on the battlefield. Each request increased the tank's weight, raised production difficulties, and stretched development time. What was envisioned as a practical machine began to evolve into something bordering on the overengineered. The first prototype rolled out in September 1942. The MAN version, which ultimately won the contract, featured a 700-horsepower Maybach HL-230 engine, interleaved road wheels, and the now iconic glacis plate sloped at 55 degrees. The KWK-42 cannon was long, sleek, and lethal, a weapon capable of piercing Allied armor at distances that would render many opposing tanks helpless. During initial testing, the cannon proved capable of penetrating this frontal armor at over 1,500 meters. German generals saw this as a necessary equalizer. They believed they had found a solution to the T-34 problem, but the race to production was rushed. In January 1943, Hitler demanded that the new tank be ready for mass deployment by the summer, just in time for Operation Citadel, the massive German offensive planned for July at Kursk. Engineers protested that the tank required more testing. The drivetrain was unproven at full weight, the cooling system struggled under prolonged strain, and the complex interleaved wheel design made field maintenance difficult. But the demand for a battlefield miracle pushed aside engineering caution. Production lines accelerated. Factories in Nuremberg and other industrial centers began assembling hundreds of units, many of them still plagued by mechanical vulnerabilities that would only reveal themselves under combat conditions. By the time the Panther officially entered service in early 1943, German crews were optimistic but wary. Training centers rushed crews through crash courses on a tank, with controls and systems more complicated than anything they had previously operated. Maintenance personnel facing an unfamiliar machine worked overtime to learn the Panther's quirks and weaknesses. Reports from training units warned that final drives were failing under stress, engines ran dangerously hot, and transmissions struggled with the weight of the tank. Still, the High Command pushed forward, convinced that the Panther's battlefield performance would outweigh all concerns. Operation Citadel launched on July 5, 1943. It was the largest tank battle in history, and the Panther was expected to spearhead the attack. But on that very morning, before the first hour of combat had passed, dozens of Panthers broke down. Some caught fire due to fuel line leaks, others suffered engine seizures, and many simply stopped moving. Of the roughly 200 Panthers deployed by the WWII Panzer Corps, more than half were immobilized before they ever engaged Soviet armor. German crews were frustrated and stunned. A tank that was supposed to symbolize German engineering dominance was failing under the pressure of real combat, yet this was only the beginning of the Panther's complex story. Those Panthers that did reach the front lines demonstrated extraordinary firepower. Their long 75 mm gun destroyed T-34s at distances that Soviet crews struggled to match. German gunners described the experience of engaging the enemy with a calm confidence they had never felt before. The glacis armor proved difficult for Soviet rounds to penetrate. In duels where the Panther was properly positioned and operational, it was terrifyingly effective, but the Eastern Front was unforgiving. Battles rarely occurred on ideal terms, and tank warfare was as much about endurance and reliability as about firepower and armor thickness. Soviet forces quickly adapted. They noted the Panther's weak side armor, its vulnerable lower hull, and its tendency to overheat. Partisan fighters and Soviet infantry learned to target Panthers immobilized by mechanical failure. The tank that had arrived with so much promise became a symbol of a deeper truth about German war production. Brilliance in design did not guarantee success without reliability. Still, the Panther's story did not end with Kursk. In the months that followed, engineers and production crews worked relentlessly to correct the Panther's flaws. New models, the Panther OSF-A and later the OSF-G, were introduced, each with incremental improvements. By late 1943 and early 1944, the Panther began to show its potential in a way that had not been possible at Kursk. German units on the Eastern Front, such as the 5th SS Panzer Division Wiking and the 2nd SS Panzer Division Das Reich, reported improved performance. The tank's reputation began to spread, both among German crews who trusted it more and among Soviet tankers who feared it. But even as its battlefield record improved, Germany faced a crippling reality. The Panther was expensive and slow to produce. Factories struggled with Allied bombing raids, material shortages, and labor disruptions. Producing one Panther required far more labor hours than the Soviet Union needed to produce a single T-34. The math of war was not in Germany's favor. Every Panther that rolled off the assembly line was a statement of intent, but also a reminder that Germany could not match the Soviet Union's industrial capacity. On the Western Front, Allied forces would encounter the Panther in 1944 during the Normandy campaign. American and British crews, accustomed to facing earlier German tanks, were alarmed by the Panther's appearance. The Sherman, the backbone of American armored forces, struggled to penetrate the Panther's frontal armor even at close range. Soldiers of the U.S. 2nd Armored Division recalled the shock of seeing 75 shells ricochet harmlessly off a Panther's glacis. Confidence was replaced by a grim understanding. This new German tank was a different kind of threat, and yet the Panther's Achilles heel remained. Its mechanical reliability was still poor. Navigating the hedgerows and tight lanes of Normandy placed immense strain on the drivetrain. Panthers bogged down, overheated, or became stuck in terrain that Shermans crossed with ease. American tankers quickly recognized that flanking the Panther was the key to survival. A well-coordinated flank attack could land shots into the Panther's thin side armor, turning the tables. In these chaotic, close-range battles, tactics often mattered more than raw firepower. This was the duality of the Panther. A machine capable of extraordinary battlefield dominance if everything worked perfectly, but war rarely allowed for perfection. By mid-1944, the Panther had become the centerpiece of Germany's armored strategy. Hitler insisted that it form the backbone of panzer divisions, and plans were made to produce thousands more. Yet even as the factories worked overtime, the reality of total war was catching up. Material shortages meant that many Panthers were built with substandard components. Substitutions in steel grades weakened armor in places, and production delays were frequent. Despite these challenges, the tank earned a reputation among its crews for sheer battlefield dominance when fully operational. Experienced German tank commanders often described it as a sledgehammer on tracks, capable of breaking the morale of any opposing crew it faced head-on. One of the most famous engagements demonstrating the Panther's power occurred during the Battle of Villers-Bocage in June 1944. The 101st SS Heavy Panzer Battalion, equipped with Panthers, was tasked with cutting off British advances. The Panther's 75 high-velocity gun devastated British Cromwell and Sherman tanks from long distances, causing confusion and panic among enemy units. Michael Wittmann, one of Germany's most celebrated tank aces, exploited the Panther's range and accuracy to inflict devastating losses. Wittmann's actions at Villers-Bocage became legendary, a demonstration not just of individual skill, but of the Panther's potential in the hands of an experienced crew. Yet even in this success, the Panther's limitations were evident. Mechanical failures and the difficulty of maintenance under combat conditions constrained operational effectiveness. Meanwhile, Soviet forces continued to adapt. Newer models of the T-34, armed with 85 guns and thicker frontal armor, began to challenge the Panther more effectively. Soviet tactics emphasized ambushes, artillery support, and numerical superiority. Even a Panther formidable in open combat could be neutralized by combined arms tactics, terrain advantage, or sheer force of numbers. The Eastern Front remained a crucible in which the strengths of the Panther were constantly tested against the vast industrial and tactical capacity of the Red Army. By late 1944, Panthers were being deployed en masse during Operation Market Garden and the Ardennes offensive. In the dense forests and narrow roads of the Ardennes, the Panther's size and mechanical complexity became liabilities. Tanks frequently became immobilized in mud or on obstacles. Maintenance crews struggled to extract broken-down Panthers under fire. American and British forces, having studied captured Panthers and intelligence reports, emphasized flank attacks and high-trajectory fire. While the Panther's main gun could dominate frontal engagements, the Allies learned to exploit its vulnerabilities, making tactical ingenuity more important than firepower alone. Despite these challenges, the Panther was regarded as one of the most advanced tanks of the war. Its combination of speed, armor, and firepower represented a technological leap for the Wehrmacht. Innovations such as sloped armor, the high-velocity 75 kW K-42 cannon, and the interleaved road wheel suspension would influence tank design for decades to come. Engineers and historians have noted that the Panther was not merely a reaction to the T-34, it represented a paradigm shift in armored warfare. It was heavier and more sophisticated than many contemporary Allied tanks, requiring a high level of crew training and coordination to operate effectively. Training became a critical factor in Panther deployment. Crews underwent rigorous instruction in gunnery, maneuvering, and maintenance. Officers emphasized the need to coordinate with infantry, artillery, and reconnaissance units, as a Panther operating alone was vulnerable despite its formidable firepower. Field reports stressed the importance of understanding terrain, as even a fully operational Panther could become a sitting target if caught in unfavorable positions. By mid-1944, veteran German tank units had developed standard operating procedures that maximized the Panther's strengths while mitigating its weaknesses, but these procedures required discipline and experience, commodities increasingly scarce as Germany faced mounting losses on multiple fronts. The Panther also shaped German armored doctrine. Hitler and the Oberkommando des Heeres, OKH, increasingly relied on it for breakthrough operations, believing that a few Panthers could change the outcome of a local engagement. In practice, this reliance was a double-edged sword. When Panthers were deployed effectively, they could wreak havoc on enemy formations. When mechanical failures, poor terrain, or inexperienced crews intervened, they could become liabilities. Field commanders often expressed frustration with the inconsistency between theoretical performance and battlefield reality. By 1945, the Panther had achieved near-mythical status, the OSF. G model, introduced in mid-1944, incorporated improved armor, a refined engine, and simplified production techniques, yet it remained a complex and costly weapon. Panther units were deployed on virtually every German front, from the Eastern Front's endless steppes to the shattered villages of Western Europe. In the final months of the war, Panthers were used defensively in desperate attempts to delay the Allied advance. Encounters at the Silo Heights in April 1945 demonstrated both the tank's strengths and its limitations. Panthers could destroy enemy armor and fortifications, yet they were increasingly isolated, vulnerable to concentrated artillery, air attack, and logistical breakdowns. The Panther's impact extended beyond immediate battlefield performance. Allied intelligence and post-war analysis underscored its significance. The U.S. Army's technical intelligence teams studied captured Panthers in detail, noting the innovative design of the K-42 gun, the sloped armor, and the interleaved wheel system. Engineers recognized that many design elements, particularly the emphasis on armor angling and high-velocity armament, would influence post-war tank development in both NATO and Warsaw Pact nations. The Panther became a benchmark, a standard against which modern tanks would be measured for decades. Yet the story of the Panther is not solely one of technical achievement. It embodies the paradox of German armored production in World War II. Brilliant engineering constrained by industrial realities, rushed deployment, and the relentless pressures of a multi-front war. The Panther could dominate in ideal circumstances, but reliability issues and the challenges of mass production prevented it from achieving the decisive impact German leaders had hoped for. Its legacy is therefore complex, part technological marvel, part cautionary tale of overengineering in wartime. Survivor accounts provide further nuance. Veterans from the 1st and 2nd SS Panzer divisions describe the Panther as a tank that inspired confidence and terror in equal measure. Crews knew that a fully functional Panther could stand alone against multiple enemy tanks, yet they also lived with the constant fear of breakdowns in the field. Maintenance logs from 1944 and 1945 reveal that for every operational Panther, one or two remained under repair at any given time. Fuel shortages compounded these problems, particularly during the retreat across France in the Ardennes, making Panther units more vulnerable to Allied air attacks and artillery barrages. The psychological impact of the Panther on enemy forces was equally profound. Allied tankers often recounted the first sighting of a Panther as shocking. The long, slender barrel of the KWK-42, the sharply angled glacis plate, and the imposing silhouette conveyed a sense of invincibility. This fear was a strategic advantage in itself, as it influenced the behavior of opposing crews, often forcing them into defensive or cautious positions that slowed their advance. In this way, the Panther contributed to battlefield outcomes not only through direct firepower, but through its reputation. The strategic significance of the Panther became particularly evident during the defensive battles on the Eastern Front in late 1944 and early 1945. As Soviet forces pressed westward in a relentless tide, German commanders relied increasingly on the Panther to hold critical positions. At battles such as Narva and the Vistula-Oder Line, the Panther was used in concentrated formations to deliver maximum firepower against advancing Soviet armor. When positioned in hull-down positions or on high ground, the Panther's 75 gun could decimate T-34s at ranges that left Soviet crews exposed and vulnerable. Its mobility allowed rapid repositioning, giving German forces a temporary tactical advantage even in the face of overwhelming numerical superiority. Yet these defensive deployments highlighted the tank's logistical vulnerabilities. Panthers consumed fuel at an alarming rate, and supply lines in the collapsing German territories were increasingly unreliable. Many Panthers were abandoned due to fuel shortages or mechanical failure. Maintenance teams struggled to keep pace with constant wear on engines, transmissions, and suspensions. Even experienced crews knew that a Panther's effectiveness was limited by support. Without fuel, ammunition, and repair crews, the tank could not survive in the prolonged engagements that typified late-war combat. The Panther also faced the increasing threat of Allied air power. By 1944, the Allies had achieved near-total air superiority in many theaters. P-47 Thunderbolts, Hawker Typhoons, and other fighter bombers hunted German armored formations relentlessly. Despite the Panther's formidable armor, repeated strafing and bombing runs caused irreparable damage to engines and tracks, sometimes destroying entire units before they could engage the enemy. The combination of mechanical complexity, logistical strain, and enemy air dominance meant that the Panther's true potential was rarely realized on the battlefield by the war's end. Nevertheless, the tank's design excellence could not be denied. German engineers had succeeded in creating a vehicle that balanced firepower, protection, and mobility better than almost any contemporary tank. The KWK-42 L-70 gun remained a deadly weapon capable of penetrating the frontal armor of virtually any Allied tank at combat ranges typical of 1944-1945. Sloped armor provided enhanced protection without adding excessive weight, while the torsion bar suspension and interleaved road wheels delivered mobility and stability unmatched by many contemporaries. In theory, a Panther could fight almost any tank on equal footing, and for a time it did. Historians have often debated whether the Panther was too much tank for the circumstances in which it was deployed. It represented the pinnacle of German engineering, but required precision, training, and maintenance to function effectively. When all these elements aligned, the Panther was nearly invincible. When any factor failed, it became a liability. This duality encapsulates a broader truth about German armored strategy. Technological superiority alone could not overcome the strategic and industrial disadvantages Germany faced against the combined might of the Soviet Union and the Western Allies. The Panther's influence extended beyond its own combat record. Captured Panthers were studied extensively by both Soviet and Allied engineers. The Soviet T-54 and T-55 tanks, which would dominate the Cold War era, incorporated concepts inspired by the Panther, including sloped armor and long-barreled, high-velocity guns. Similarly, post-war German and Western designers recognized the value of mobility combined with firepower and armor protection, lessons learned directly from the Panther's battlefield performance. In many ways, the Panther set the standard for what a medium tank could achieve, influencing decades of tank design philosophy. One of the most remarkable aspects of the Panther was the way it shaped the psychology of tank warfare. German crews often described a profound confidence when operating the Panther, a sense that they could face superior numbers and still prevail. This confidence translated into aggressive tactics and, in some cases, extraordinary battlefield successes. The combination of firepower and armor made the Panther a force multiplier, allowing smaller German units to hold ground against larger enemy formations. At the same time, the presence of Panthers had a demoralizing effect on opposing forces. Allied and Soviet tankers often reported that encountering a Panther in open terrain produced fear, hesitation, and even tactical withdrawal. Yet the Panther's operational record is a study in contrasts. The very features that made it formidable, complex engineering, interleaved wheels, high-performance engines, also caused frequent failures. Field reports from 1944 indicate that up to 30% of Panthers in frontline service were often non-operational at any given time due to mechanical problems. Engine failures, transmission breakdowns, and track damage were common. The logistical burden of supplying fuel, spare parts, and train maintenance crews was immense, straining already stretched German resources. The Panther's battlefield dominance was therefore contingent not only on crew skill, but on an extensive support network that the deteriorating German war economy could rarely sustain. Despite these challenges, the Panther continued to demonstrate its lethal effectiveness in the closing months of the war. During the defense of the Silo Heights in April 1945, Panther units engaged Soviet armor in desperate attempts to delay the Red Army's advance toward Berlin. Accounts describe Panthers destroying multiple T-34s in single engagements, their long-barreled guns delivering devastating accuracy at ranges exceeding 1 kilometer. However, mechanical failures, ammunition shortages, and overwhelming Soviet numbers meant that these victories were often temporary and came at a high cost in crew casualties. The final campaigns of the Panther were marked by bravery and skill, but underscored the limits imposed by strategic circumstances beyond the tank's control. The Panther's legacy extends into the post-war period. Military analysts, tank designers, and historians have consistently recognized it as one of the most sophisticated tanks of World War II. Its combination of armor, firepower, and mobility represented a synthesis of lessons learned on both the Eastern and Western fronts. The interleaved wheel suspension system, although difficult to maintain, provided stability and smooth movement across rough terrain. The high-velocity KWK-42 gun set new standards for anti-tank performance. Sloped armor inspired generations of tank designers worldwide. Even today, the Panther is studied as an example of how technological innovation can redefine armored warfare. At the same time, the Panther serves as a cautionary tale. It highlights the challenges of producing complex weapon systems in a total war environment. Mechanical reliability, production efficiency, and logistical support proved as decisive as design brilliance. The Panther's failures at Kursk, Normandy, and during the Ardennes illustrate the consequences of overengineering and rushed deployment. Yet its successes, both tactical and psychological, demonstrate that when properly employed, the Panther could dominate the battlefield in ways few other tanks could match. In examining the Panther, one sees the intersection of engineering genius and wartime necessity, ambition and limitation, innovation and practicality. It was a machine born out of urgency, inspired by an enemy's design, and perfected under extreme pressure. Its story encompasses both triumph and tragedy. Triumph in the battlefield victories it achieved, tragedy in the mechanical failures and strategic constraints that prevented it from altering the course of the war decisively. The Panther remains to this day an enduring symbol of German armored innovation, a tank capable of inspiring awe and fear in equal measure. Even as the war drew to a close, the Panther continued to fight in scattered engagements across the collapsing Third Reich. In the Ruhr Pocket and the defense of Berlin, Panthers were deployed in desperate attempts to stem the Allied advance. Crews often faced overwhelming odds. Infantry swarmed with anti-tank weapons, artillery pounded defensive positions, and Allied armor advanced in overwhelming numbers. Yet in many instances, the Panther's presence alone slowed enemy momentum. Accounts from both German and Allied sources describe situations in which a single Panther, positioned advantageously, could hold a junction, destroy multiple tanks, and delay an entire column of infantry and armor. This final phase of combat further illustrated the dual nature of the Panther's design. In optimal conditions, it was almost invincible. However, with fuel scarce, ammunition limited, and mechanical breakdowns inevitable, Panthers often became immobile targets. Crews learned to improvise, using debris, destroyed vehicles, and buildings to augment their tanks' defensive positions. Engineers created field repairs under fire, attempting to coax engines back to life or replace broken tracks. The war's chaotic final months forced Panthers and their crews to operate far beyond the limits originally intended by their designers. By May 1945, the Panther had left an indelible mark on both German and Allied perceptions of armored warfare. Allied intelligence officers conducted exhaustive studies of captured tanks, reporting to superiors on every aspect of the Panther's design, from the angle of its armor to the characteristics of its engine and transmission. These analyses informed post-war armored doctrine and influenced the design of tanks such as the American M26 Pershing, the Soviet T-54, and later the German Leopard 1. The Panther's engineering, while never flawless, demonstrated that combining mobility, protection, and firepower in a single platform could produce a weapon of unprecedented battlefield effectiveness. Historians evaluating the Panther have debated whether it could be called Germany's perfect killing machine. On paper, it possessed nearly every attribute desired in a medium tank. Superior frontal armor, a high-velocity gun, impressive mobility, and a psychological impact that few contemporaries could match. In practice, mechanical unreliability, logistical constraints, and the pressures of multi-front warfare prevented it from achieving the strategic dominance Hitler had envisioned. Yet no discussion of World War II armored vehicles would be complete without acknowledging the Panther's remarkable capabilities. Even when faced with overwhelming enemy numbers, inexperienced crews, or poor terrain, the Panther remained a formidable opponent, capable of turning the tide in localized engagements. The Panther's operational history also reflects the broader story of German armored strategy. Germany relied on technological sophistication and battlefield superiority, often at the expense of mass production and reliability. The Panther exemplifies this approach, brilliant in concept, devastating in effective use, but hampered by industrial limitations and the realities of total war. It embodies the tension between innovation and practicality, illustrating how even the most advanced weaponry can be constrained by circumstance. Beyond its historical and tactical significance, the Panther has endured as a cultural and military icon. Museums worldwide preserve surviving examples, and historians, modelers, and reenactors study its design meticulously. Its reputation, whether for battlefield lethality, mechanical complexity, or innovative engineering, continues to inspire fascination. For German crews, it represented a blend of pride and frustration. For Allied forces, it symbolized a daunting adversary. The Panther's legacy is therefore twofold, a testament to engineering ingenuity and a cautionary tale about the limits of technological superiority in war.